Hello, today we're going to solve an interesting integral from the MIT integration bee from the year 2022, so a very recent one. So let's see how we do this. So actually we're going to apply a common trick with some of these definite integrals involving trig functions. We're going to make the u sub u equals pi over 6 minus x, which means that x equals pi over 6 minus u, and also that dx equals minus du. So this is a common substitution that we can do to switch these bounds, and we'll get some nice simplifications. So let's see what we get. So let's see, we plug in 0 into x here. That means u is going to be equal to pi over 6, and then if we plug in pi over 6, we're going to get zeros. So we're going to get the integral from pi over 6 to 0 of the log of the square root of 3 plus the tangent of pi over 6 minus u du, but we have to put a minus sign in front because of our dx equals minus du. So now firstly we can use this minus sign to switch these bounds again, and we'll get a very similar integral. So let's see how we do that. So we're going to get the integral from 0 to pi over 6 again. Now nextly, essentially we can just switch u for x again, because that's just an irrelevant variable for our integral. So we're going to get, let's see, pi over 6 minus x dx. Now we're quickly going to do some trigonometry. So let's see, we've got this tangent of pi over 6 minus x. Let's just quickly derive the formula for tangent of alpha minus beta. So we got tangent alpha minus beta. So some easy trigonometry here. So let's also just look into tangent of pi over 6 to make our life a little easier. That's just going to be sine of pi over 6 divided by cosine of pi over 6, which means it's going to be 1 over square root of 3, or square root of 3 divided by 3. So we're going to get the integral from 0 to pi over 6 of the natural log of the square root of 3 plus, and then we're going to use our sum, or our formula for tangent alpha minus beta. So we're going to get tangent of alpha, which was 1 over square root of 3, minus tangent of x, divided by, let's see, 1 plus 1 over square root of 3 times tangent of x, all in brackets, dx. So obviously this looks horrendous, so let's maybe multiply by the square root of 3 to get some things cleaned up. So we're going to multiply both the numerator and the denominator by square root of 3, which is going to give us in the denominator square root of 3 plus tangent of x, and then here we're going to get 1 minus square root of 3 times the tangent of x. So now that we've got that, we can get rid of all of this. Let's now deal with this square root of 3. So let's maybe get it into the same denominator. So we're going to get the integral from 0 to pi over 6 of the natural logarithm, and then we're going to get square root of 3 times the square root of 3 plus tangent of x. So that's going to give us 3 plus the square root of 3 tangent of x, and then of course plus 1 minus the square root of 3 of tangent of x, all divided by square root of 3 plus tangent of x, and then dx. Right, so nice. We've got this pretty significant simplification of this square root of 3 minus square root of 3, and we're going to get 4 in the numerator. Next up, we can split this log up into two pieces. So we can use log rules, like the log of a over b is going to be equal to the log of a minus the log of b, so pretty basic stuff there. And we can use that to get this integral from 0 to pi over 6 of the natural log of 4 dx minus the integral from 0 to pi over 6 of the natural log square root of 3 plus tangent of x dx. And now we can see something nice. So if we look at the extreme left-hand side of this equation and the extreme right-hand side of this equation, we can see the same integral twice. So in essence, we can now construct, by adding the integral to both sides of this equation, we can now construct this identity. So we're going to get 2 times the integral from 0 to pi over 6 of the natural logarithm of the square root of 3 plus tangent of x dx is going to be equal to, let's see, log of 4 is going to be 2 times the log of 2 times x evaluated from 0 to pi over 6. So that's just the basic integral. That's just a constant we're integrating over. So lastly, we can divide by 2 to get this result, and then we can plug in these values, which are going to give us the log of 2 times, let's see, pi over 6 minus 0, so that's just going to be times pi over 6. So in the end, we've got log of 2 divided by 6 times pi. So thank you so much for watching. I hope you enjoyed this integral from the MIT Integration Bee. I've got loads more. They're really interesting oftentimes, and they use some new techniques like this, a nice substitution that you can use in loads of integral cases where there is some trig functions involving pi over 6, pi over 4, maybe pi over 2. You can use this so often. So thank you so much for watching. If you have any tips for me, definitely let me know. Till next time, thank you so much.